Let's quickly go through the main functionality of the application, which is question answering over a collection of documents. I've selected a document here. It's called AMEM. It's a paper on agentic memory systems, particularly the AMEM method. So let's get started. I will click on the mic icon.
Hello, I am seeing one selected document that I can answer questions about.
Can you summarize the paper abstract?
All right, let me quickly pull together a clear summary of the abstract for you. The paper, AMEM, Agentic Memory for LLM Agents, proposes an agentic memory system that helps LLM agents better use past experiences during long-term tasks. The authors argue that existing memory systems mainly support simple storage and retrieval, with rigid structures that limit adaptability. AMEM is inspired by the Zettelkasten method. Each new memory is turned into a structured note with contextual descriptions, keywords, and tags.
Which
Then,
other algorithms is AMEM compared against?
let me check what baselines it's evaluated against so we can list them clearly. AMEM is compared against the following baseline memory agent methods: Locomo, Read Agent, Memory Bank, MEMGPT. In some experiments, especially on DialSim and additional foundation model comparisons, the paper compares AMIM mainly against Locomo and MEMGPT.
And which datasets were used in the study? Can you describe them?
Let me walk through which datasets were used and what each one is meant to evaluate. The AMIM study used two datasets. One, Locomo, a long-term conversational QA dataset with much longer dialogues than typical conversational datasets. It averages about 9K tokens and spans up to 35 sessions. It evaluates an agent's ability to handle long-range dependencies and maintain consistency over extended conversations. It includes 7,512 question-answer pairs across 5 categories. Single hop, answerable from one session. Multi-hop requires synthesizing information across sessions. Temporal reasoning tests understanding of time-related information. Open domain knowledge require combining conversation context with external knowledge. Adversarial tests whether models can identify unanswerable questions. 2. DialSim, a question-answering dataset derived from long-term multi-party dialogues. It is based on popular TV shows, Friends, The Big Bang Theory, and The Office. It covers about 1,300 sessions spanning 5 years, with roughly 350,000 tokens. It includes over 1,000 questions per session, drawn from refined fan quiz questions and complex questions generated from temporal knowledge graphs. It
Who
evaluates
are
the...
the authors of this study?
Let me check the author list so I can read it back accurately. The authors are Wu Jiangshu, Zhujie Liang, Kai Mei, Han Gao, Juntao Tan, and Yangfeng Zhang.
Do any of these authors have papers in the references section?
Let me scan the references for any matching author names. Yes, the overlapping ANIM authors found in the references are Juntao Tan, appears in reference 21, Agent Light, a lightweight library for building and advancing task-oriented LLM agent system. Kai Mei and Yangfeng Zhang appear in reference 23, AIOS, LLM agent operating system.
Okay, let's take a look at some of the settings that control how this application functions. So the most important is the OpenAI API key. So essentially in this application, we're using the OpenAI models. So we need this API key. To generate this key, you can go to platform.openai.com, create an account if you don't have one, generate a key, and make sure it's funded. Otherwise, this application cannot function. Okay, so this is the model section of the settings. So for the different aspects of the application, different models are used. For example, for the voice part, we use GPT Real-Time 2. For the question answering, we use GPT 5.5. The idea is that you can override these models. Let's say GPT 5.6 comes along, then you can, set it here if you want to. I won't go over all of the settings here because you can get the help by clicking this question mark icon. It explains all of these settings in detail. I'll just point out just a couple of them. So reasoning level, it's set to low so we can get the answers faster, but for more complex questions, you can set it to higher value. Max answer tokens essentially just limits the length of the answer that the model generates. I'm going to talk about this setting called max tool calls. So when you ask a question, that question is actually relayed to the answer model, which is GPT 5.5 in this case. Now, the model may be able to answer the question from the context that is in its memory, or it may decide to get more context, in which case it will ask the application to run a query and give it more search results. So that query is actually given to the application in the guise of a tool call. So application then searches the index with that query, return the results. Now the model may have enough context to answer the question, or it may decide to get more information, in which case it will issue another tool call. So essentially the model can go into this tool call loop. So this caps the number of tool calls that the model can go into before it generates the answer. And once it reaches this number of tool calls, it's forced to generate the answer. If it's less than that, then this limit doesn't really apply. Now you can, for complex queries, you can increase this value. Of course, you might get a better response, but the latency will also be higher. So 8 seems to be a reasonable number for most queries. Another group of settings relates to parsing or ingesting indexing PDF documents. So the three main settings are layout analysis, enrich keywords, describe visuals. In layout analysis, for each page of the PDF document, a small machine learning model is used to understand the layout of the page. Is there a heading there? Is there a subheading? Where is it? Is there a visual or a table? Where is that visual or table? And that metadata is then included into the main content. So the content has more context for better question answering. Enrich keywords. Okay, so there are two indexes created for each document. So one is a semantic index, which is vector-based, and the other one is a keyword-based index. For the keyword-based index, we extract the keywords from the content, but if enrich keywords is on, then a small GPT model is used to enrich those keywords by adding synonyms and related terms, again, to improve the context around the content. Describe visuals. So for each visual on the page, we will send a picture of that to a small GPT model and have that picture be described by the model. And that description is also included in the content. Okay, let's index a document. So first, I want to make sure that I have activity logging turned on to verbose so we can see more detail while the index is running. I'm going to increase the font size a bit here and then pick the AMM document for indexing. Okay, so here you can see that it's starting to process the PDF. One of the things it needs to do is to initialize a machine learning model uh, in the Onyx format so that it can score each page and determine the different clusters on the page for the different topics, such as not topics, but the parts of the page, like the title, subtitle, picture, etc. Okay, so here you can see it's now going page by page. So for each page, it's applying this model. It's determining how many clusters are there, and then it will classify those clusters, and then we can use that metadata, the information, to enrich the document content with additional context. So I'll let it run and pause the video here. Okay, so here the application is now getting these visuals described. So it's found 9 visuals in the paper. It's now asking GPT Mini to describe those visuals so it can enrich the content further. Here we're processing the keywords. So the keyword metadata generation is happening. Essentially, it's taking terms from the document and finding synonyms and additional related terms, again, for better enrichment of the context around the content.